Consider a single autoclave within the dyeing process in a previous exercise. The orders to be processed by this autoclave are so structured in groups within this table. Here you have an example of 5 orders. Can you see here the order ID? That's the type of yarn, the color, but this is that doesn't mean anything to our problem. This is the weight. That's very important in our problem, as you will see later on, and this information about the customer will be also so important. Then these customers have been our customers since 1997 and these years. So the question is, which order shall I produce at first? So this is not the real number for the orders. This is like an identification number. But maybe this number 5 will be processed at first. So I don't know. So the question I want to answer today is, which position will have every order ID within this table? So our intention is to serve first large heavy orders, but we want to weight them by seniority. So if we have 2 orders that weight the same, we will make the difference depending on how long this customer has been our customer. Then this will be the priority. How heavy is the order will be the priority for this order. So this priority can be stated, this is the hint of the problem, can be stated depending on some fractions. 1/1, 1/2, 1/3. So an order wants to be the first, in the first position, 100%, as you can see here, 1/1. Another wants to be the second, half the value. He wants to be the first. So here you have 1/2. 1/3 is the priority another has to be the third. So another wants to be the first, but wants the half to be the second, wants the third to be the third, wants the fourth to be the fourth, and so on. So the problem is characterized this way. The autoclave can process 150 kilograms at a time, so that's why all these numbers are multiples of 150. Big orders are so divided into batches of 100 kilograms each, but that's not of our interest. This is about how the process works, how the production process works. Each autoclave processes 150 kilograms. It lasts 75 minutes, so that's not of our interest. So we can go on without this information. But this information is so important because the manufacturer policy leads us to serve firstly the senior customers. So these customers, they have been working for so long with us. The manufacturer policy also leads us to serve the large orders first. So that's why the weight will be affected in order to have the final position by the customer seniority. The orders of a single customer should be processed in a pack, so one next to the other. So the interlacing of orders from different customers is forbidden. So if you start to produce with this customer, you must continue with the same customer. You cannot change between customers for this example of 5 orders. You're expected to formulate the corresponding binary optimization problem according to the MATLAB environment, despite this problem could be manually solved. First of all, I will define the optimization array that will have 25 elements. Why? Because I have 5 orders to be assigned in 5 possible positions. The meaning for x1 that it's a binary variable, false or true, this variable goes for order 1 in position 1, as you can see here. Order 1 in position 1. x2, that is also binary, all of them are binary variables, goes for order 1 in position 2, and so on. So, for example, x24 is order 5 in position 4. Well, what about the Cos function? The Cos function will be will be a linear combination on the elements of the optimization array, as you remember of our lectures, from our lectures. So, first of all, what about the seniority determined by this column, customer, since? Let's suppose that we are in 2018. Then you make the difference because you know that this customer has been working with you since 1997. So you do the difference and then you have 21 years for this customer. The same goes for the other customers, and the numbers are 16 and 3. So these preferences will be determined by the weight of each order. So pay attention. How much the first order weighs? 300 kilograms. So the preference for this first order to be in the first position is 300 divided by 1, the 100%, you remember from the previous slide. Then, what's the preference for the same order to be in position 2? Is half the preference, as you can see here. So it's 300 divided by 2. So this order doesn't want to be in the last position. That's why when I change the position, when I go down in the table, the number that divides the weight is increasing in order to make these values lower. So what about the second order? It goes the same, but now the weight is 150 kilograms. So the procedure is the same, 150 divided by 1 for the first position, 150 over 2 for the second position, over 3 for the third, and so on. So as you can see here, these are the weights of the orders, and the increasing numbers on the denominators leads us to lower values as long as you go down in the table. So finally, what's the linear Cos function? As you may remember, the Cos function is a linear combination on the elements of x. And this linear combination means that you must get all the coefficients that multiply every element within the array x, within the optimization array. So here we have also a negative number. What about this negative number? It's because we want to maximize the Cos function, and MATLAB only knows how to minimize. That's the reason. So we change the sign for maximization. So what about C? C can be built as follows. Can you see here? This is the seniority for the first customer. Can you see here? That's the seniority of the first customer. Then 300/1 is the weight, depending on the weight and the position. Then the same, absolutely the same seniority goes for the same order, number 1, but on the second position. Then the same seniority for order number 1 on the third position, on the fourth, and on the fifth position. What about the next 5 numbers? The next 5 numbers, they have the same coefficient at first, because it's the same customer, as you can see here. So the seniority for this same customer is absolutely the same. So 21, 21, 21 for the next 5 numbers. But what about the weight? The weight is half the previous one. So that's why 150 is divided by 1, 2, 3, 4, and 5, because this is the preference for this second order to be in position 1, 2, 3, 4, and 5. What about the third? The third has a weight of 450, so that's the reason for this numerator in here. 1, 2, 3, 4, 5, it's absolutely the same. And what about this 16? This 16 is because we suppose we are in 2018, as I told you before. And here we have 2002, so if you make the difference is 16 years. Finally, the last element, as you can see here, dots, and then the final element in this cos function is the last order. Can you see here 5, that weighs 600 kilograms. 600 kilograms is the preference to be the last, so it's divided by 5. And the seniority is only 3 years old, so that's why here it appears a 3. What about the equality constraints? First of all, each order must be assigned to a position. So, all the elements within the array X that belong to order number 1, all this addition of the addition of all these elements must be equal to 1. So this way I'm forcing only one out of these 5 possible values to be 1. All the remaining one, the 4 remaining numbers, will be 0. Why? Because I know that every element on the optimization array is a binary element. So if I admit only one number 1 in here, all the remaining numbers will be false, 0. So the same goes for order number 2 in here, order number 2, 3, 4, and 5. As you can see, when you move to a new equation, you add 5 positions, obviously, because you add 1, 2, 3, 4, 5 positions. What about the second set of constraints, that is, each position receives a single order? What about now we look the table from the top. What about the first position? The first position, here we have a candidate, order number 1, another candidate, order number 2, 3, 4, and 5. So only one out of these 5 orders will be in position number 1. So x1 plus x6 plus x11 plus x16 plus x21 will be equal to 1. And the same goes for the remaining positions. So we have the second set of equality constraints, because I'm forcing only a single order to be equal to 1, to be assigned to this position. Finally, what about the inequality constraints? You remember? This customer, all the orders that belong to this customer must be assigned together. So, the same goes for the second customer. So, if you have a look at the original table, as you can see here, position 1 and 2 belong to the same customer, and 3 and 4, they belong to another customer. So they must be produced one after the other in a pack. So here we have, first of all, order 1 must be next to order 2. If order 1 is in position 1, order 2 cannot be in positions 3, 4, and 5. So that's what I'm telling here. Let's have a look here. Order 2 in positions 3, 4, and 5 are these elements in here, 8, 9, and 10. So that's why x1 plus x8 must be smaller or equal than 1. Why? Because this way I'm assuring that x1 and x8 both cannot be 1. Maybe this will be true, so maybe order 1 will be in position 1. But for sure, if this is 1, so order 1 will be in position 1, order 2 will not be in position 3. Why? Because if both have a value of 1, this inequality is broken, is violated. This condition is violated, so it cannot be true. So I'm excluding one to the other. So if this is 1, this cannot be 1. If the second is 1, the first cannot be 1. The same goes for the second inequality, is for order number 2, as you can see here, in position 4, and this in position 5. And all the remaining inequalities are built the same way. So you can stop the video at this moment and have a review of all these conditions. How can I translate everything into a MATLAB environment? First of all, the Cos function, as you can see here, is an array of 25 coefficients. It's the seniority, the weight, and the preference to be in every position, 4 and 5. Look at the negative number in here. Then I build the inequality constraints. So no interlacing of customers is this matrix. As you may remember from the preceding videos, inequality constraints are of this kind. So this matrix A is built thanks to this and these assignments. These are for order 1 next to order 2 for this customer. This is for order 3 and order 4, this customer. Finally, we have the equality constraints, and these equality constraints are A equality multiplied by X equal to B equality. And this A equality is this. As you may remember, the first 5 elements, this is because each order must be assigned to a single position, then the second 5 members of the X array, and each position receives a single order. As you remember, this is for the first order, the second order, the third order, the fourth, and the fifth. So finally, we call the int limproc.m function. I must give MATLAB this input argument. This f is the coefficients. This is the array of coefficients for the Cos function, and then this means that from x1 till x25 all of them are integers. So this name comes from integer linear programming. This Cos function is linear because it's a linear combination of the elements on X. But these elements in X, all of them from 1 to 25, are integers. Then the matrix is A equality, and the arrays B equality must be given. Remember that the B are these independent elements on the inequality or equality constraints. Then zeros 1, 25 is an array full of zeros. These are the lower bounds. Why do we need these lower bounds? Because now we know, or we tell MATLAB, that these elements in X are integers, but we want them to be 0 or 1. That's why this is the lower bound and this is the upper bound. The upper bound, this. Finally, this is the result. As you can see, this is the before and this is the after. As you can see, customers, all the orders belonging to the same customer are produced as a stack in a pack. As you can see, the final assignment is far different from the original one. And as you can see, you can check this problem could be solved manually because we only need to do this product, the weight, by the seniority. You remember 2018 minus these years, okay? And state the preferences dividing by 1, 2, 3, 4, 5 in order to state the preferences for every order in every position. But the reason for this video was to show how sorting orders problem can be stated within a MATLAB environment.